Any questions? Before break, we did the moving average using Excel. Okay. We also use different alpha to say how can we get the best predicting model. Use alpha 0.1, 0.2, etc. Yeah. So now we are going to use Excel to do exponential smoothing. Okay, exponential smoothing. How do I use Excel to produce exponential smoothing? Okay, we are going to use the same data. That is the computer cells. Okay. So go to chapter 4, and then I will want to copy data into a new sheet. Maybe I'll just put it here. Okay, so I will start from here. We did manual calculations using Excel as a tool. Now you can use data analysis in Excel to produce exponential smoothing for this data. Okay, so you go to data analysis, exponential smoothing. Okay, so input range, the original data is input range. Damping factor is 1 minus alpha. When alpha is 0.1, so damping factor is 0.9. Okay, and output range, I want to put output here. Okay, click OK button. So this is, let me check with my, yeah, this is when alpha is 0.1. Okay, this result is the same as we get before break. So I just format the data so that it has 2 decimals. Okay, so similarly, you can do when alpha equal to 0.2. Just repeat yourself. There is no way to do once for all different alpha when you use data analysis. So just change the input range is the same. Damping factor is 0.8. Damping factor is 1 minus alpha. Output, I want to put the output in D25, in D column. So D25 here, I want to put output here. Click OK button. Okay, so this is the output. So keep on going. 0.3, when alpha equal to 0.3, go data analysis, exponential smoothing. When alpha 0.3, damping factor 0.7. This time the output I want to put E5, $E, $5. OK button. Okay, so this is 0.3. So any questions? You keep on going to produce exponential smoothing for other alpha, different alpha. Now I just format so that it has 2 decimals. Any questions using exponential smoothing? And once you have this exponential smoothing, you can produce a graph line chart. Okay, so using alpha 0.1, you can select these 3 columns together, insert line chart. Series 1, series. Sort here. So something like this. Okay. Any questions? Any questions? All right. So we did that. We also did double exponential smoothing at the beginning part. Okay. So now I'm going to select some questions from textbook. To solve questions from textbook. Page 138, question 8. I'll just copy this question so that I can make annotation. All right, let's do question 8. The data is in table pH. Where is pH? I have to copy the data pH. Here, this table. Copy. Paste here. Won't work. Paste picture. No, copy and paste won't work. So I just copy screen. Here. So this is the data. But we also need using Excel. So get the data from Excel. It is textbook. This is chapter 4. pH here. Oh, not too bad. It's just pH. Yeah, that is the data. Okay. Okay, question 8a. What is the forecast for period 9 using a 5-period moving average? So go question. So maybe I will just copy this into my week 4. I have week 4 data. So this is from problem 4-H. for question 8. So what we are asked to do, forecast period 9 using 5 moving average, 5 period moving average. One, 2, 3, 4, 5. So I put result here. 5 period moving average equal AVER ATE. 5, 1, 2, 3, yeah. And then copy down. So if you want to know which one is 1, you insert a column. So this is period 1, period 2. So forecast for period 9. So we need to continue copy down. So the answer is 221.2. Okay. Any questions? Question B. If simple exponential smoothing with a smoothing constant 0.4 is used, what is the forecast for time period 4? So alpha equal to 4 using exponential smoothing. Okay. So go to data analysis, exponential smoothing, input range. So this is my input range. Damping factor 0.6. Damping factor equal to 1 minus alpha. Output result I'll put here. Click OK button. The entry cannot be damping factor D2, B2. Input range, I need to reselect input range. Looks like this is my input range. Okay, and then click OK button. Your entry cannot be used. An integer or decimal number may be required. Damping factor 0.6. Input range D2. Okay, so this is my exponential smoothing forecasting result. The forecasting for period 4 is here, 208.4. Okay, 208.4. So this is question B. Question C, in part B, what is the forecast error for time period 3? Question C, forecast error for time period 3. So for period 3 is here, forecast error equal to original number minus forecast number. The answer is 11. This is forecast error for period 3. Period 3 of I did period 4 for period 3. Yes, this is period 3. Okay, the answer is 11. So any questions for question 8? Question 8. Okay. Let me see, question 9. Pick another question. Question 12. So next I will do question 12. Question 12. question 12, use data P. All right. So question 12. Genuine American Investors Company, a closed-end regulated investment management company, invests primarily in medium and high-quality stocks. Jim Campbell, you studied the asset value per share for this company. Would like you to forecast the variable for the remaining quarters of 1996. This is 1996. The data presented in P12. This is the data. This is the data. What? P12. So forecast and following forecast method. So it is asked you to use naive method, using moving average, using exponential smoothing. So 3 different methods. Then you need to evaluate these 3 methods. Okay. And write a brief report. So we are just focusing on those 3 methods. Okay, 3 methods. So I'm going to open data P-12. -12. So I'm going to copy. P-12. Where did I put? Maybe there are too many data here. This is chapter 4, problem. -12. All right, remember what is naive method? Try to write down the formula for, we have different naive methods. So we have, okay, so first of all, we have different naive methods. I'm going to, that is on page 136. All right, so those are the naive methods. Okay. So which one would you suggest and why? Just try to copy those naive methods into OneNote. Any suggestions? which one would you use? We have different models for naive method.
Hi, Professor. I think I would try exponential smoothing just because if you put a line graph of the data, it looks like there's some peaks and valleys.
She's asking for the naive part, though.
Oh, sorry.
She's asking what part for naive. I would say the seasonal model for quarterly data.
Okay, so before we do that, the first step, you need to produce a line chart to explore data pattern. Okay, so let's produce a line chart. Thank you so much for your participation. So where is my, okay. So let's produce a line chart. To produce a line chart, you also need X value. So I'm going to insert time t. Period is 1, 2, etc. Okay. So after that, you select these two columns and insert line chart, this one or this one, maybe this one. So this is the line chart. Okay, I'll try to copy to OneNote because I want to make annotation. Maybe put it here. Paste. It is here. I'll try to move this. It's can't go. Okay. So now let's check one by one. The first one is said the next period equal to looks not. Okay, so we eliminate this one. Oops. The second one, naive trend. We do have trend looks like. Okay, so we may select this one. Okay, and the next one is the naive rate of change model. Next one, seasonal model. Seasonal model for quarterly data. Let's say, the question said, this is seasonal data, see quarter, but not if you have quarter data, not necessarily it is a seasonal, okay? And to check if it is a seasonal or not, you need to produce auto correlation coefficient because that one will tell you. But oops, my battery is low. Give me 1 second. Right, so I plug in. By just examine this line chart, do you have maybe because I have Excel here. Let me go to Excel to produce auto graph for this data here. Copy and then file new. So I pasted this data and I will change the value. This is the value. Okay, now I go analyze forecasting autocorrelation. Value is my variable. And then I press OK button. It does not look like seasonal data, although it is quarter data. Okay, so based on this autocorrelation graph, so we may not use the seasonal model. Maybe just use the naive trend model is good enough. Okay, if you are not sure you can try each of those, and then you compare the MAD, MSE, PE. Okay, so for illustration purpose, I will just select the second one. The first one for sure not on our list. Okay, that does not mean this one is not good. You can try. Okay, so we just do next one. This one said the forecast for next one, T+1 is next period equal to the current period plus current minus the one before. Okay, so let's do this forecast. So we use naive. So it is said the next one, so we start with the next one. The next one equal to the current one. This is the current one plus the current one minus the one before, but we don't have one before. So we have to start with the next one here. This one here. This is our T+1. So equal, this is T plus opening bracket T minus T minus 1. I pause for a moment to see if you can make connections between Excel formula and this this formula here. T+1 equal to T plus bracket T minus 1. Any questions? Okay, and then I will just copy down. Okay, so this is the naive method. And then we are asked to use moving average and exponential smoothing. And when you're using the moving average, how do you know you use a 2-period moving average, 3-period moving average, or 4-period moving average? How do you know? Any suggestion? How do I know using 2-period moving average, or 3, or 4, or 5, or 6? Any suggestion? Oh, one question said, why the basic naive not work? Because when we explore data in the plot, we found the data has the trend. Naive means if data does not trending up or trending down, you can use naive, the first model. Okay. So for moving average, what would you suggest to use? You can try 2 moving period, 3 or 4 or 5. Okay, remember one example I did, I tried K equal to 2, K equal to 3, K equal to 4. You can follow the same method, then and try to select the best model. Where is that one? K equal to, yeah, here. You can try to use K equal to 2, K equal to 3, K equal to 4, and calculate MAD, MSE, MAPE. Then select which moving average is the best. Okay. And for illustration purpose, I will just do maybe 4 moving period, just for illustration purpose. Okay. So for 4 moving period, you can do 4, 1, 2, 3, 4. So put the result here. Okay, 1, 2, 3, 4. Yeah. So you just do equal average. So I'm doing 4 moving average, 4 period moving average. And then you drag it down. That is 4 period moving average. Okay. So lastly, for exponential smoothing. And when you do exponential smoothing, how do you know which alpha to choose? There is no alpha given. You have to pick one. Okay, again, follow the example I gave you. When alpha is not given, you try alpha 0.1, 0.2, 0.3, 0.4 until 0.9, and then pick the best alpha. I already did this. I will repeat myself for that exercise. Okay, but for illustration purpose, I will pick maybe any alpha. So let's say alpha 0.3. Okay, just for illustration purpose, alpha equal to 3. When alpha equal to 3, what you need to do? Okay. So first of all, you need to initialization the first number and the second number here. The first number equal to y1, the second forecast number equal to y1, and then you calculate yt plus 1 based on this formula. So let's do this. Suppose alpha 0.3, just for example, okay? So when alpha equal 0.3 or 0.3, so the first number equal to original number. The second number also equal to original number. The next number, I will try to show the formula here. So that you can compare. This is the formula, okay? It is 4.13. Okay. So next number equal to alpha, so 0.3 times the number before it. This is t plus 1 times t. This is t, okay? And plus 0.7 times t y hat t. So this is this formula, okay? And then copy down. Drag it down. Okay, so that is the exponential smoothing. After you did this 3 method, naive method, moving average method, exponential smoothing, you need to calculate MAD, MSE, MAPE. Remember we did a couple of times in class. And then you pick up which one out of these 3 methods, which one is best. You write a report. Okay. Any questions? Okay, in summary, what we did today, we actually emphasize on Excel implementation of moving average, exponential smoothing. We also discussed the formula for double exponential smoothing. Double exponential smoothing has a name, hot linear smoothing. And we also did 3 parameters for Winter's method. Okay. That's all for today. Any questions?
Oh, yeah. Dr. Fu, could you please show 4-12 again, please?
I'm sorry, which one?
Just the last one you're showing us.
Sure. This one?
Yeah.
Okay, so this one, I will delete the whole stuff and redo it. Is exponential smoothing. You need to pick up a number, okay? So I just pick exponential smoothing. Here, we use this formula, textbook 4.13. When you use exponential smoothing, you need to specify an alpha. Suppose alpha is 0.3, okay? So this method said, forecast for period 1 equal to y1. This is forecast for period 1. It said equal to y1. 16.98 is y1. This is forecast for period 2. It is said equal to y1 again. So forecast for period 3, you need to use this formula. It is here, yt plus 1/2. See where's my mouse? You use this formula. So this formula said you need an alpha value, for example, 0.3 times, 0.3 times yt. This number is yt, 18.47 yt, and plus 0.7 times yt hat. This number is yt hat. I pause for a moment so that you can see, compare the formula in Excel with the formula from textbook here. Y hat t plus 1 equal to alpha times yt plus 1 minus alpha times yt hat. Okay.
Thank you.
Thank you for asking. Any other questions? So when you press enter, you then just copy the formula. Okay, if you cannot double click, you just drag it down. That's it. That is your forecast. All right. Okay, thank you so much for your participation. If you have further questions, you can also email me. Please allow 2 business days to have your email answered. Okay, thank you again. Good night. See you next time.